Hello! Now that we know how to apply forces on bodies, we know about the three motion laws, Newton laws, we can solve problems, find accelerations, find tensions in ropes on systems. So let's start. First demonstration. Let's say I have this mass, which is 10 kilograms, and I want to know, just a minute, and some external force pulls it with a force of 120 newtons. I want to know everything. I want to know its acceleration, I want to know the forces, I want to know everything. So first thing you need to do in every problem that you get, to apply forces. Even if you are not asked to do so, do so. We know mg is downwards, we can calculate it because m is at 10 and g is also 10. 10 times 10, 100 newtons. Up is the normal force. And to the right is an external force which is given to us 120. Now when we analyze the problem, we separate it, the x-axis and the y-axis. Let's start with the y-axis. In the y-axis, we know that this object, this mass, doesn't go up or down. Okay? So what does it mean? According to the first law of Newton, if a body remains in its state, it doesn't go up or down, it remains here in the y-axis, it means that the total force is zero. And in other words, this force must cancel this one, the same magnitude, the opposite length, the opposite direction, sorry. So normal must be equals to 100 newtons. This is why the normal is 100. Let's talk about the x-axis. Obviously, I pull it here, it will accelerate, it will start moving. There is no force here that can cancel it. So it must move. The total force in the x-axis is not zero. So what Newton says? Newton says that this force that is applied on this object must be equal to the mass times the acceleration. And if we put numbers, 120 is equal to 10 times a. A is equals to 10. The unit is meters per second squared. I said that we deal with accelerations later when we learn kinematics, but the idea is that every second, the velocity accelerates by 12. For example, if it's in rest mode in the start, after 1 second, the velocity will be 12, another second, the velocity will be 24, 36, 48, Okay, this was the first example. Let's continue. Now I want to see this example. Let's say this mass m1 is 10 kilograms, this mass m2 is 20 kilograms, and the force here, external force, someone pulls this system, it's like a train, with a force of 60 newtons. And again, I want to know everything. All the forces, the accelerations, the normal force, everything. First of all, we apply forces. So, downwards, it's mg. Instead of writing mg, I'll write the numbers. m1 is 10, 10 times 10, it's 100 newtons. Upwards is n1. To the right, tension. This one. Downwards is 20 times 10, it's 200 newtons. Up is N2. To the left, T. To the right, it's an external force, it is given, it's 60 newtons. First, I apply forces. Now I look at the system, I look at this drawing and say, what will happen to it? I will analyze it in the Y direction, I will analyze it in the X direction. One more thing, I have two masses here. For now, just for now, we are going to analyze it, each mass separately. Let's talk about this one And then let's talk about that one. Let's start with the left, with this mass, with M1. And when we analyze it, we ask ourselves what happens in the Y direction, what happens in the X directions. Let's talk about the Y. Again, we know that it is in rest mode in Y because it doesn't go up nor down. So N1 must be equal to 100 newtons. This is the normal force. In the X direction, it must accelerate, obviously, to the right. Why? Because there's a force here, nothing there, must go over to the right. And Newton says that the T, the total force, which is T, must be equal to the mass times the acceleration. So the T is equal to the mass times acceleration. This is about M1. Let's talk about M2. Also, what happens in the Y, what happens in the X. In the Y direction, again, it doesn't go up nor down, so M2 must be equal to 200 newtons. In the X direction, we know that it will accelerate to the right. Why to the right? Why not to the left, for example? Because when I pull it, the tension is a passive force. It comes after I pull it. It can't initiate movement. This one pulls it, and due to this one, the rope gets tension. So this one must be stronger than that one. And again, when you look at it from at the whole system, you know that if I pull two mass with ropes to the right, it's obvious that this system will go to the right. It won't move to the left. So, what is the total force in the X axis? We say always all the forces in the line of motion minus all the forces against the line of motion. The motion is in this direction. So 60 minus T is the total force in the X direction. This must be bigger than that one, otherwise it won't accelerate. This minus that must be equal to 20 times A. I want to find A, I want to find T. So what we can do, two ways. I want to show, well, let's talk about the one way, but we won't use it. We'll use the other way. First of all, you can just put 10A and place it here. What I want to show you, always when you solve these kind of problems, write these two equations, one under the other, T equals to 10A, and add them up. When you add them up, the T will go, so you will have 60 is equals to 12A, so A will be 5 meters over second squared, and if you want to find the T, just place 5 here, so 10 times 5 is 50 newtons. Now I know everything I need to know about this system. For example, let's just demonstrate it. I know that this mass, it doesn't feel the 60, it feels only the T, it feels only the 50 newtons. This mass also, it doesn't feel the 60, it feels 60 minus, where am I? I think I didn't copy it right. This is 20, this is 30, sorry, this is 2, and 10 times 2 is 20. Okay, so again, if I want to understand what this mass feels, this one will feel 20, it is pulled by 20, and 20 is equals to 10 times the acceleration, 10 times 2. This mass is pulled by 60, but it's also pulled in the other way by 20, so this mass will only feel 40 to the right. And 40 is, like Newton says, is 20, the mass, times the acceleration. 20 times 2. Okay, another example. We're going to do a lot of examples. Okay, so 3. Let's take this one out too. Okay, another example. Okay, M1 equals 10, M2 equals 40 kilograms. Again, I want everything. I want to know the normal forces, the tensions, the acceleration, everything. First of all, applying forces. Down is mg. mg is 10 times 10, 100 newtons. Up is normal. To the right, t. Let's go to this one. Down, mg. mg is 40 times 10, is 400 newtons. Up, t. That's it. No normal here, no surface here. Again, let's look every object separately and let's understand where the line of motion is. This object, the line of motion is to the right or to the left, obviously to the right. This one is also it's only up or down, obviously down, because the system, if you just try to think about it, when we place a mass here, a pulley, rope, and the mass here, it will probably go down unless there is friction. Today we don't deal with friction. So this system of mass will obviously accelerate this direction. Later on we'll see that it doesn't matter, even if you think that it will accelerate that direction, it won't matter because the mass will give you the result you need. We'll see it later. Let's talk every mass separately. Let's talk about M1, let's talk about M2. M2. Okay, and again, we'll talk about the Y and the X. Also here, the Y and the X. Let's start with the Y. We know it doesn't go up nor down, so N must be equal to 100 newtons. X, all the forces in the motion direction, minus all the forces opposite, which is none here, will be the mass times the acceleration according to the second law. So T minus nothing is equal to 10 times acceleration. Let's go to this one. Here there is no X factor here because there are no forces here, and obviously this mass doesn't go left nor right because the total here is 0. So nothing to write here, it's obvious. In the Y direction, I know it accelerates down. So 400 must be bigger than the tension. They are not the same because if they were the same, it wouldn't accelerate. So what I write is all the forces in the line of motions, which is 400, minus all the forces against, which is t, equals to the mass times acceleration. And again, to solve this problem, write every equation, one under the other. Let's write like that. And add them up. When you add them up, you will get 400 equals to 50 times A. A is 8 meters per second squared. And the tension, if I want it, I just place 10 times 8, 80 newtons. And what does it mean, this solution? That this mass, it doesn't feel the 400, it feels only 80. And 80 is really equal to 10 times 8. This mass doesn't feel the 400, it feels the 400 minus 80. And don't tell me I had another mistake, or it's okay. 400 minus 80 is, no, it's okay. 400 minus 80 is 320, and it really equals to the mass times 8. 40 times 8 is 320. It's okay. Okay. One more. 4. Okay, let's do something extra here, exactly the same system, but I apply also a force here, external force. Let's say this mass is 20 kilograms, this mass is, it doesn't matter, 10 kilograms, and this force is, let's say, 8 newtons. Again, I want everything. I want forces, accelerations, normal, everything. First of all, we apply forces. Down 200 newtons, 20 times G. Normal force. This is external force, it's just 8. This one is tension. This one, tension. This one, M times G, 100 newtons. Now there's a little problem. Why? When I look at the line of motions, how do I know which way the masses will go? This way or that way? Two things I have to tell you about that. First of all, it doesn't matter if you are wrong. If you are wrong when you solve the problem, you will get a negative. Negative means that instead of accelerating that direction, it accelerates the other direction. But you can know. How you can know? Look only at the external force in the line of motions. This is not a line of motion. It doesn't matter. The line of motion is here to the left or to the right, and here is up and down. So I look only in this direction. This mass is pulled down, this system is pulled down by 100 newtons. The tension are external forces. They don't initiate the movements, you have passive forces. Don't think about them when you think which way the system will accelerate. So you have 100 here, and someone pulls, let's say a little bigger, just to make it more, okay, 80 newtons, let's say. So someone pulls it 100 here, and the gravitational force pulls it 100 newton here, and someone with a rope, I don't care how, pulls it 80 here. Who will win? Of course the 100. So the system will accelerate that direction. And if you understand it, just when you write the equation, make sure this is the line of motion. The forces on this direction must be bigger than the forces on the other direction. Okay, so let's solve it. Let's go to M1. In the y-axis, N equals 200 because it doesn't move up or down. It doesn't matter. In the x-axis, now that we have decided that the direction of motion will be to the right, this force must be bigger than that one. So we'll write T minus 80 equals to, all the forces in the direction is T, all the forces against is 80, T minus 80 equals to the mass times acceleration. This is about the M1. Let's talk about the M2. X direction we don't have, only the Y direction, and we know it accelerates down, so this one must be bigger than that one. So we will write all the forces with the line of motion, which is 100, minus all the forces against, which is T, equals to the mass times A, the acceleration. Let's add them up, these two, and if we add them up, the tension will go, and we'll have 100 minus 80 equals to 30A. So A equals to 20 and 30 is 1.5. Sorry, 2/3. 20, okay, it's 2/3 meters per second squared. And if we want the tension, we just calculate it. I didn't bring my calculator today. This is a very big mistake I did, but nevertheless. 20 times 2/3 is 40/3 plus 80, which is, this is 15, 16, I think, 16 1/3. This is a very big problem for me to calculate these things. It doesn't really matter. Okay, so what is our conclusion? That this object is pulled down with 100 up with this force, and if you do that minus that, you will get the total force it feels in the y direction. This force, this mass will feel this 80 plus something to the right, only 80 to the left, so the total force this will feel in the line of movement is only 40 over 3, 40 divided by 3. And it will accelerate according with the second law of motion. If you take 20 and multiply it by 2/3, you will probably get this one. Okay, one more. We are 5. Okay, let's do this one. Okay, we have 2 ropes over a pulley. This one is 10 kilograms, this one is 20 kilograms, this is M3, is again 20 kilograms also. I want to know the acceleration of this system and the forces on the rope, everything. First of all, apply forces, then we'll talk. Down 100 newtons, 10 times G. Up T1. Why T1? 2 ropes, 2 tensions. Okay, this one, T1, because it's the same rope. Down 2 forces, T2, and also mg. mg is 20 times 10, it's 200 newtons. This one, up is 2, down 20g, which is 200 newtons. Okay, we have 3 masses, so we'll have 3 equations. If we want to guess the line of motion, just neglect the interior forces, which are the ropes. Just think about the external forces that pulls the systems, which are the gravitational force. This way, this system is pulled by 200 and 200, it's 400. This way, it is pulled only by 100. And the ropes just adjust to this. So, which way will this system go? Obviously, it will go that direction. This one will go up, these 2 will go down. This is the line of motion. So, let's do the calculation. Let's start with the M1. What can we say about the M1? If this is the line of motion, this one must be bigger than that one. So, T1, all the forces with the direction, minus 100, which are against, is equal to the mass times multiplied by the acceleration. 10 multiplied by A, the acceleration. Let's go to M2. A little more complex. More forces. These are the forces. Only these. So what can we write about the M2? All the forces in the motion direction, which is down. So this one and this one. Sorry. 200 plus T2. This one and this one, minus T1, which is against the line of motion, equals to the mass, which is 20 times acceleration A. Notice that the acceleration of the system is exactly the same. So this body accelerates exactly as this one, because they are all attached to each other. If that one accelerates in a certain rhythm, this one must accelerate in exactly the same rhythm. So the A and A here must be exactly the same. M3, also this is the line of motion, so this one is bigger than that one. So 200 minus T2 equals to 20 times A. Mass times the kilogram, the acceleration. Let's add them all up. If we add them all up, T1 minus T1, go. T2 minus T2, go. So what we will get is minus 100 plus 200 plus 200 minus plus equals to 10, 20, 50 A. So we get 300 equals to 50 A. A equals to 6 meters per second squared. And if we want the tension, T1 and T2, We can calculate them easily from here, for example. 10 times 6 is 60. It will be 160 Newton. And if we want the T2, let's go here. 20 times 6 is 120. We go here, then it will be 80 newtons. Let's see. So this mass feels 160 up, 100 down, so it feels only 60. And 60 is really 10 times 6. This mass feels 160 there, 80 here, 200 here, so it feels 280 minus 160. 280 minus 160 is 120. 120 down is really equal to 20 times 6, the mass times the acceleration. This mass feels 200 down, 80 up. 200 minus 80 is 120. 120 is really equal to 20 times 6. So the laws of motion, Newton laws of motion, really work here. Okay, 6. Okay, more. Let's do more complex. Okay, this one, that one, and I apply also external force here. Okay, M1 is 10 kilograms, M2 is 30 kilograms, M3 is 10 kilograms, and let's say F is 200 kilograms, 200 newtons, sorry. Okay, again, I want to know everything. First of all, we apply forces. 100 newtons, normal 1, T1. 300 newtons, normal 2, T1, T2. 100 newtons, T2. That's it. Again, look at the line of motion. This is not the line of motion as far as these two masses are concerned, because they don't go up nor down. The normal will be 100 here, 300 here. They really won't affect, unless there is friction, but still, we don't deal with friction today. Unless there is friction, we don't really care about them. The line of motion will be right, left here, or up, down here. So let's look only on the external forces. The gravitational force pulls the whole system, it pulls the whole system with 100 Newton here. So 100 Newton to this direction. And an external force pulls it 200 Newtons in this direction. So which way this system will move or accelerate? It will accelerate that direction, because this external force is bigger than that one. And we neglect the internal force because they are passive. They adjust themselves after we decide which direction this system will go. So let's go M1. M1, we know that M1 is equals to 100 newtons, but really I don't care about it for now. I want to know only the line of motion. This must be bigger than that one because it accelerates to the left. So we say 200 minus T1, that minus that, equals to 10 times acceleration. Let's go to M2. Also, N2 is equals to 300 newtons. We write it, but we will not deal with it for now. And in the x direction, in the motion direction, this one must be bigger than that one because it accelerates to the left. So we say T1 minus T2 equals to 30A. M3, we know that it moves upwards because this is the motion direction. So T2 minus 100 equals to 10 times A. So we have three equations. If we add them up, let's look again. Minus T1 plus T1 goes. Minus T2 plus T2 go. So what we will get will be 200 from here. nothing from here, minus 100 equals to that plus that plus that, it's 50A. So A will be 2 meters per second squared. And if we want the T1 and the T2, we just calculate it from here. 10 times 20, 120. And the T1 we can get from maybe here, okay. 30 times 2 is 60. 60 plus 120 is 180. Let's see how it goes. This object feels 200 here and 180 here. So it feels only 20 here. 20 really equals to 10 times 2. This object feels 180 here, 120 here. So it feels 180 minus 120, it feels only 60 here, 60. 60 really equals to 30 times 2. This object will feel 120 here, 100 here, so it's only 20 here if we subtract it. So 20, it really equals to 10 times 2. I want to show you another thing. I say that I knew this equation without doing all that. How did I know it? If I look at this system as a whole, not like with different objects, I just assume it's one big mass. And I neglect the tensions are internal forces, I neglect them. So I say, I know that this system will go this way, so I say all the forces in this direction, which is 200, minus all the forces in that direction, which are 100, 200 minus 100 must be equal to, according to the second law, the mass of the system multiplies by the acceleration. The mass of the system is 10, 30, 10, is 50. 50 times A. So I knew it without writing it separately. All the forces, external forces in the line of motion, minus all the external forces in the other direction, must be equal to the mass of the whole system multiplied by the acceleration. Now, if you do so, it's okay, but if you are asked later on in the exercise to calculate what the tensions, you must do this. So it's good to know it and use it to find acceleration. It doesn't help you when you want to find tensions. When you want to find tensions, you must go separately to each mass. Okay, one more. Seven. Okay. Let's go back to this. M1 equals 30, M2 equals 20, and F we don't know. Let's deal with this problem let's ask three different things. First of all, what is F if we know that A is 2 meters per second squared in that direction? Okay? What is F? What must be F if we know that the system accelerates in this direction by 2? Again, it doesn't matter what they ask. First of all, we apply forces. So, we have 200 here, newtons, tension, 300 newtons normal, tension of course, and the F. Now, if I know, let's start dealing with this one. If I know that the system will accelerate this direction, I know that this force must be bigger than that one, and this one must be bigger than that one. I can solve it two different ways. looking at one mass separately, every mass separately, or looking at the system as a whole. When you solve problems, try to look in every mass separately. It's better for you, but know that you can also look as a whole. Let's do two different ways. One way, I look everyone separately. So if I look at M1, if this is the line of motion, this is the direction, this one must be bigger than that one. So T minus F equals to 30 times the acceleration, but we know the acceleration is 2. What happens with it? And also N equals 300, but we don't deal with it. M2, it accelerates downwards, so 200 is the force with the line of motion, minus T equals to 20 times 2. Here I don't even have to add, okay, let's add them up. If I add them up, I can find the tension easily from here. But if I add them up, I get 200 minus F equals to, this is 60, this is 40, 100. So F must be 100 newtons. This is one way to solve the problem. Second way to solve the problem is, as I said, look at the system as one, as a whole. I neglect the tensions and look only at the external forces. The gravitational is external because the Earth is pulling it, and this is obviously external because someone pulls it. I'm talking only the line of motion. This is not external. Also the Earth pulls it, but they cancel each other. So they are not in the line of motion. I don't care. So I know the system accelerates here. So all the forces in the direction is 200. Minus all the external forces in that direction, which is only F, must be equal to the mass of the whole system, 50, multiplied by the acceleration, which is 2. And again, you'll see F is equals to 100 newtons. Okay, second problem. Again, what will be F if the acceleration is also 2? But in this direction, that direction. Again, let's solve it two different ways. First way, every mass separately. If it accelerates this direction, this one must be stronger than that one. So, if I talk about M1, F minus T will equal to 30 multiplied by the acceleration. Then we know the acceleration, 2. And if we talk about this one, the M2, all the forces with the line of motion, which is T, minus all the forces against, which is 200, must be equal to 20 times the acceleration. Let's add them up. F minus 200 equals to 60 plus 40, 100. F equals to 300 newtons. Second way. We know it accelerates here. Let's talk only about the external forces of the whole system. Let's look at this as a 1. All the external forces in this direction is F, minus all the all the external forces on this direction, which is 200, must be equal to the mass, which is 50, multiplied by the acceleration, which is 2. And again we get F 300 newtons. The third problem I can be given is what is F if this system does not accelerate. Does not accelerate, it means A is equal to 0. What does it also mean? A equal to 0 means that the velocity doesn't increase nor deduct. So, this system, if it's not increasing this direction or that direction, it stays in its state. It remains in the same state. If it was resting, it will remain resting. First law of Newton. If it had any velocity, some velocity, it will remain in the same velocity. So A equals to 0 doesn't mean it rests. It means staying in the same state. If it had velocity, it will continue with the same velocity. If it was at rest, it will continue rest. I don't know which state it was, but I don't really care, because the first law, Newton's first law, will be okay if it was in it had velocity, and if it was in the rest mode. So let's deal with it also two different ways. First of all, each mass. If I know that this doesn't accelerate, which means it remains in its state, F must be equal to T. This is what Newton said, first law. This one must cancel that one, M1. And M2, it also remains in its state. So T must be equal to 200. And if I just, put 200 here, F must be 200 newtons. This is the first way to solve it. Second way to solve it is, again, look at the external forces and look at the system as one mass. The external forces is 200. The external forces is F, and they must be equal because this system remains in its state. It doesn't accelerate. So F is 200 newtons. Okay. Very nice. One more. Okay, so we are 8. Let's do much more complex. When I say complex, it means more forces, but the idea will be exactly the same. Let's do that one. Okay, and again this one. Okay, M1 equals to 10 kilograms. M2 equals to 20 kilograms. M3 equals to, again, 20 kilograms. And let's put another forces here, F1, F2. F2 equals to, I don't care, 300 kilograms, 300 newtons, sorry. Okay, I want to know everything. I want to know tensions, I want to know accelerations, I want to know everything. First of all, we apply forces. Let's start with this one. Downwards is 300, which is external force, it is given to us. One more force is, of course, the gravitational force, 100 newtons, 10 times G. Up is T1. That's it. This one. 200 newtons, okay. And, okay. T1, the same tension. T2, because it's another rope. This one. Downwards is 200 newtons, 20 times G. Also downwards is F1 because, and T2. These are the forces. Now let's see which way this system will go or not go, just looking at the external forces. Don't look at the tensions, and don't look at this axis because it doesn't go up nor down. It's not the line of motion. The line of motion is this one or this way. Okay, this mass is pulled down by 100 and 300 is 400, and it pulls all the system 400 on this direction. This mass is pulled down by 200 and 100, which is 300 in this direction. And these forces are passive, they adjust themselves. So 400 here, 300 here, it will accelerate this direction. Let's just show what will happen if we are mistaken. Let's say it accelerates that direction. And we know this is wrong, because we know it accelerates on the other direction. But let's see what happens if we assume this direction. I can also solve it two different ways. I can solve it as a whole, I can solve it each mass separately. We'll do them both. Let's start each mass separately. First way. Let's talk about M1. So all the forces with the line of motion is T1, minus all the forces against the line of motion which are 100 and 300, which is 400 newtons, must be equal to the mass times the acceleration, 10 times A. M2. We said this is the line of motion, so T2, this was T1. T2 minus T1 must be equal to, the mass is 20 multiplied by A. And let's go to M3. We said this is the line of motion, so 300 down minus T2 must be equal to 20 times A. Let's add them up. T1 goes, T2 goes, so minus 400 plus 300 must be equal to 50. A is equals to minus 2 meter per second squared. What does it mean, minus 2? It means that we assume wrong. It means that instead of accelerating that direction, it accelerates this direction. That's what it means, but the answer is still 2. But when you solve the problem and you write that your answer, you say the acceleration is 2 meters squared, 2 meters over second squared, that direction. You don't put the minus or the plus, you always write it with absolute value 2, but you add the direction, left, right, this way, that way. If we want to find the tensions, use exactly the same answer and place it there. Let's say we want the T2. T2 will be 20 times minus 2 is minus 40. Minus 40 from, so it's 340 newtons. And T1 will be, let's put it here, minus 40 plus 340 is 300 newtons. Let's see if it makes sense. This is 300, this is 400. 400 minus 300 is 100. 400 minus 300 is, it doesn't make sense. 400 minus 300 is 100. 100 doesn't equal to 10 times 2, so I have a little mistake here. Maybe here. 300, 150, just a sec. This looks fine. T2 maybe. Minus 40, it looks fine. 340.